So to start with, silos. These are just some example silos of data inside of a construction company. There are very few systems that are connected together. The norm is data is created inside of a silo, does not flow to other silos. Information is constantly recreated by different departments. Very rarely flows from pre-con through construction, is quite often created, and that not only wastes a lot of time, it's a huge opportunity to introduce errors into the process. So at Vico, what we're trying to enable is to break through these silos, connect the different departments together, let the data flow, let it be reused. And I'll talk as we go forward about how we're doing that. Of course, as many of you have probably seen before, the core part of our data flow is how we connect things from a 3D model. So for example, we could take a very basic box inside of a 3D model that represents a column, but modeling systems don't know what that column represents as far as tasks you have to perform and items that you need to buy to perform them. So what we do in our system is we connect that box in a CAD model to the things that you need to do to get that built. So a column, you have to erect the rebar, erect the formwork, pour the concrete, put on whatever the cladding is. Inside of our system, that's non-graphical data. It's really best represented by the combination of the cost plan and the scheduling plan, but it's designed to be connected to the model. What the model can do is give you very accurate information about the number of these columns and then properties from these columns. So for example, the surface area, vertical surface area in particular, that would be used for formwork and cladding, volume that would be used for the concrete, and other properties that you would no longer need to calculate manually. This layer really represents tasks, or the methods. We subdivide those into the labor, equipment, and material that you have to purchase to build that object. This content is highly reusable, so on every project you're probably going to have concrete columns. The formulas may vary a little bit for the rebar. The cladding will vary according to the design, but for the most part, once you have the content, it's highly reusable, and it makes it much faster to produce an estimate. Whenever the design is changed, the estimate will be updated. If the size of the columns are changing, for example, the volume will flow through to formulas inside of the resource level, and that will be used to update the cost. So that represents the data flow that we use to connect the model to cost, but not yet really to time. Yes, this layer does represent task, but it's too granular for the way we want to plan and control schedules. If we had 500 columns in the project, you wouldn't want to have 4 methods for each one of them. You wouldn't want to have 2,000 tasks essentially to track. So we needed to aggregate these back together to match how you really do plan construction today. And we do that by adding zones to the model. Some zones are already inherent in the model, for example, floors. But on top of those, we can also draw zones, so essentially just draw a boundary to represent zone 1, a boundary to represent zone 2. And then the system can look at zone 1 and say, is there anything that is concrete inside of zone 1? If there is, a pour concrete task is automatically created. Everything that is concrete, so for example the slab, will be cut automatically by our system, so it will be separated at zone 1 and zone 2. We'll calculate the quantities that exist inside of zone 1, so you get location-based quantities automatically from our system. If you add a production rate for how fast your crew can consume those quantities provided from either the super or the subcontractors, then we're able to calculate the duration of those activities and generate a schedule. So what the scheduler does is add the logic and also work on balancing the schedule, manipulating it to make it faster and also to reduce risk in the system. They don't have to worry about task creation, duration calculation. That actually comes as automated behavior from the system. Because the cost plan drove the schedule to begin with, the schedule is automatically cost and resource loaded if you did estimate at a resource level. That's important to point out that you can be as granular as you want in this data structure. If you're working at a very high level, if you're a CM, you don't self-perform anything, you can work at a subcontractor level of granularity. If you're self-performing this, or if you want to track your subs at a very detailed level, you can have very detailed resources, detailed tasks. The system will support either method. Regardless, whenever the design is changing, that will flow back through the system, and the schedule, again, the resource loaded, the cost loaded schedule will be automatically updated. So a lot of the manual work that is required in both cost planning and in schedule planning control is automated, allowing the estimator and the scheduler to spend time on more high-value activities, focusing on optimization.